Okay, so this is example 210. An airplane is in level flight at a velocity of 150 meters per second and an altitude of 1,500 meters. When its wheel falls off, what horizontal distance will the wheel travel before it strikes the ground? Still another. It's ITS. No apostrophe there. Okay. All right. So for this one, the idea is this. The plane's moving horizontal. This is horizontal. But what happens is the wheel falls off. So what the wheel does is it actually has two motions. It starts falling, right? Because of gravity. But it's also moving horizontally because of its initial speed. So what will happen is the Earth will pull it faster and faster toward the ground, so it'll go faster and faster to the ground. But it will keep moving essentially at the same speed horizontally. So it'll do this kind of path like this until it strikes the ground. Okay. Now the ground is 1,500 meters up. So our height is 1,500 meters. So all we have to do to begin with, this is kind of two steps, is we got to find out, step one, how long does it take for the wheel to hit the ground? And that's easy because it's just free fall. We didn't throw it down, it's just falling. So that's like previous problems, 1/2 gt squared. And we saw in some previous examples that when you do that, t is going to be 2h over g square root of that. So that tells us how long it takes for it to hit the ground. But there's a second motion, and that's the horizontal motion. So this is like going back to the beginning of the chapter. And what we said was that if something is in constant motion or constant velocity, then the change in position, the change in x over the change in time is just equal to the velocity or the speed. So in other words, speed is equal to the distance traveled over time. So if we want to know the distance that it travels here, we could just multiply both sides by time, and that would give us the distance traveled. Okay, so in a way, it's two problems. What you're doing is you're breaking it into two. The first is the vertical falling. So that's your free fall. The wheel falls straight down, or it doesn't fall straight down. The wheel falls down. It's accelerated by the Earth toward the Earth. And we can use the free fall equation, h equals 1/2 gt squared, to figure out how long it takes for it to hit the ground. Then what we do is once we know that amount of time, how long it took for it to hit the ground, we can say, hey, the wheel is also moving in this direction because it's with the airplane, right? So when it disconnects from the airplane, it's still going to move this way, but it's going to start falling. So that's why you get this projectile motion like this right here. Okay, so let's find the time that it took for it to hit the ground. That would be the square root of 2 times 1,500 meters divided by g. Okay, so that's the square root of 3,000 meters. And I'm just going to round this to 10 meters per second squared, just to show you. You can plug it into the calculator and use your 9.8 to get a little bit more accurate. So your time then would be the square root of 300, and that's meters over meters, so that's seconds squared. Okay. Then you take the square root of 300. Okay. So the square root of 300, let me just go ahead and do that real quick on my little calculator here. 300, the square root of that is about 17. Comes out to 17.3 seconds. So in other words, if you drop a wheel from 1,500 meters, it takes about 17.3 seconds to hit the ground. but it's also moving horizontally, so it's going to land somewhere over here. For that, what we can do is we could just use speed equals distance over time, or velocity equals distance over time. Either one is fine. So the distance traveled would just be the velocity times the time. Okay. So that looks like it was moving at 150 meters per second this way. So that's 150 meters per second. And now we've decided that it takes 17.3 seconds for it to hit the ground, right? So what I'm going to do is take 150 and I'm going to multiply it by 17.3, and I get about 20, it's pretty close to 2,600. So I'll say 2,000. 600 meters. And it's not uncommon for people to convert that to kilometers. So 1 kilometer is 1,000 meters. Kilo's 1,000. So that gives you 2.6 kilometers. Okay. Again, one assumption I made, or kind of estimate I made here, was I used 10 for G. It's really 9.8. So that's going to give you a slightly different answer, but it should be relatively close. Okay. So surprising, interesting, right? If you drop the wheel, it actually moves a couple of kilometers forward of when it was dropped because of this projectile motion.